If you're looking for a popular, powerful, and easy-to-learn programming language to kickstart your software development career, the IBM Java Developer Professional Certificate is for you. Java development is a rewarding and lucrative career choice. According to Indeed.com, Java developers can earn $138,000 or more annually. Java skills are in demand across various industries, including gaming, healthcare, retail, and finance. IBM reports that Java offers significant advantages over other languages and environments, making it suitable for almost any programming task. Java was designed to be easier to write, compile, debug, and learn than other programming languages. Java is object-oriented, which allows you to create modular programs and reusable code. Java is platform-independent, and you can easily move programs from one computer system to another. Java's robustness, ease of use, cross-platform capabilities, and security features have made it a programming language of choice for worldwide web-based applications. This comprehensive end-to-end program is designed by deeply experienced industry experts and features videos, glossaries, coding cheat sheets, numerous hands-on labs, and shareable final projects. You can also review what you've learned using practice quizzes and prove your knowledge with graded assessments. You don't need prior programming or software development experience to take this program. You don't even need to have a degree. Already a developer? This program is ideal for adding Java to your skill set, making you even more marketable to employers. Next, let's explore what you'll learn. You'll begin with an introduction to software development covering key concepts, practices, and career opportunities. Begin your Java programming journey by building strong foundational Java programming skills. Start with a detailed understanding of the Java development environment. Then, learn basic syntax, data types, and control structures, and practice working with arrays, functions, and string handling for efficient coding. Next, discover how to use conditional and switch statements to guide program flow, how to optimize logic with loops, and master exception handling. You'll complete this course with the skills needed to develop reliable and efficient Java programs. Then, you'll explore advanced object-oriented programming in Java, including file handling, data structures, date and time manipulation, and external service integration, all essential skills for creating sophisticated applications. Java plays a crucial role in enterprise web development. The HTML, CSS, and JavaScript course provides hands-on experience building dynamic, interactive web pages using the full-stack ecosystem, essential tools, and IDEs. Master version control with Git and collaborative coding on GitHub. Learn how to manage repositories, develop strategies for teamwork, and learn how to build your own portfolio using open-source projects. You'll also gain expertise and experience with cloud-native, microservices, containerization, and agile practices. Explore Spring, a key Java framework, and learn how to use its features for easier microservices-based enterprise-level software development. Next, learn how to develop Java applications that connect with databases. This program features a capstone course, where you'll complete a shareable Java development project to showcase your skills to potential employers. Enhance your job readiness with the Software Development Career Guide and interview preparation, featuring insights from industry experts. Finally, stand out to employers by demonstrating your ability to generate code, optimize applications, debug efficiently, and develop innovative solutions using AI tools like ChatGPT, GitHub Copilot, Google Gemini, and IBM Watson X, all while adhering to ethical best practices. We're excited to be a part of your learning journey and look forward to your success. Sign up today and jumpstart your Java development career. Welcome to this course that introduces you to Java programming for beginners. Java remains a key language, with multiple sources reporting that more than 90% of Fortune 500 companies use Java because of its scalability, ease of use, security features, and vast ecosystem. According to TalentUp, the future is bright for developers with Java skills. The number of Java developer roles is projected to grow 22% through 2030. With ZipRecruiter reporting experienced Java developers earning up to $148,000 annually. Next, let's check out the course and what you'll learn. Begin with learning about why Java is popular. Then, learn how to install and configure Java, discover how to use the Java Development Kit, Runtime Environment, and Virtual Machine, and compare Java's commercial and open source tools. You'll learn about memory management and complete this module by successfully writing, compiling, and running your first Java program. Next, you'll explore basic programming constructs including basic syntax, data types, control structures, and string handling. You'll gain practical experience working with data types and arrays to solve real-world problems. Then learn to write efficient Java code that leverages functions, methods, and control structures. You will learn how to use conditional statements, switch statements, string handling techniques, loops, and other control structures to optimize program logic. Finally, you'll learn how to handle errors using exception handling. You'll learn how to implement custom exceptions and run code regardless of exceptions. You will practice and apply the skills you learn throughout the course to develop a practical Java application that can be used in your daily life. Each module contains a reference glossary and a code summary document that contains the complete code examples referenced in the videos with that module. Use these resources as a part of your ongoing learning. The final module also contains a clickable glossary for fast location of terms. This course is perfect for anyone looking to get started as a software developer or Java developer. Whether you're just starting your career or looking to reskill, this course delivers foundational Java knowledge and experience to help you become a Java developer. In addition to earning your course certificate, this course is one of the foundational courses for the Java Development from IBM Professional Certificate Program. You only need a computer and a dependable internet connection. This course does not require prior software development experience, and a previous degree is not required. However, if you're already a developer, this course is ideal for adding Java to your skill set. Designed for flexibility, you can complete the self-paced course in about 9 hours and study based on your schedule. To get the most from this course, watch each video, gain experience with the hands-on labs, review each reading, and check your learning with practice quizzes. Use the glossaries and check out the code samples. To pass the course, prove your knowledge with the graded quizzes and the final project. We look forward to hearing about your success. You can do this. Good luck. Welcome to this video on the history and evolution of Java. After watching this video, you'll be able to describe Java and its key applications. You'll also be able to discuss the history of Java and list its key versions and features. From powering your favorite apps to forming the backbone of massive enterprise systems, Java is the unseen force driving the technology we rely on every day. Let's explore Java, a language that has shaped technology for over 2 decades and continues to grow and improve with every line of code written. So, what is Java? Java is a high-level language that lets developers build applications that can run on almost any platform. Its versatility is best captured by the phrase, write once, run anywhere, or WORA. This means that once you write a Java program, you don't need to rewrite it for different platforms or devices. Java applications can run on computers, phones, and tablets without modification. Java is used across a wide range of applications. Many web applications, websites, and online services are built using Java due to its scalability and reliability. Java is the primary language for developing mobile apps, enabling developers to create powerful, user-friendly mobile experiences. Additionally, enterprise software relies heavily on Java, as large companies use it to build robust business applications that support their complex operations and manage large volumes of data. Now, let's peek into Java's long and illustrious history. Java's history started in 1991 when James Gosling and his team at Sun Microsystems developed a programming language called Oak. Initially intended for devices like TVs and VCRs, Oak's potential was later recognized for web development. In 1995, Oak was renamed Java, inspired by Java coffee from Indonesia. With the official release of Java 1.0, the language debuted in the programming world. It quickly gained popularity due to its focus on ease of learning and strong emphasis on security, making it an appealing choice for developers. In 1998, Java 2 was released, bringing significant advancements including Swing for building graphical user interfaces and the Collections framework for more efficient management of groups of objects. Then, in 1999, the Java 2 Platform, Enterprise Edition, or J2EE, was launched. This platform simplified the development of large-scale business applications by providing tools and frameworks specifically designed for enterprise-level needs. In 2006, Sun Microsystems made a groundbreaking decision to make Java open source. This move allowed developers worldwide to contribute to its development, fostering a global community focused on improving the language. It also paved the way for the creation of numerous libraries, further extending Java's functionality and versatility. Then, in 2010, Oracle Corporation acquired Sun Microsystems, taking control of Java's development. This shift brought consistent updates and introduced new features, further enhancing Java's capabilities and ensuring its continued growth in the programming world. Next, let's dive into the key versions of Java and their features. Launched in 2004, Java 5 introduced several powerful features that greatly enhanced the language's flexibility and usability. Generics allowed developers to create classes and methods that could work with any data type while ensuring type safety. Annotations provided a way to add metadata to code, improving error checking and documentation. The enhanced for loop also made it easier to iterate through collections, improving code readability and reducing the likelihood of errors. Java 8, released in 2014, brought some exciting updates that made coding easier and more powerful. Lambda expressions allowed developers to write cleaner and more concise code. The Stream API made working with collections simpler by allowing data operations in a more functional, straightforward way. Additionally, the new DateTime API replaced the old complicated classes, making working with dates and times much easier and more accurate. Java 11, an important long-term support or LTS release launched in 2018, brought some key improvements. One standout feature was the HTTP Client API, which made it easier for developers to send HTTP requests and work with web services. Java 11 also introduced a new garbage collector feature, which improved memory management and boosted performance, especially for large applications, by reducing the time spent on garbage collection. Launched in 2021, Java 17, another LTS release, introduced pattern matching for instance of, making code cleaner by reducing boilerplate. It also added sealed classes, giving developers control over which classes can extend or implement them. Finally, in 2023, Java 23 was released. This version included features like record pattern for deconstructing records and pattern matching, and streamlining data handling. Virtual threads, another Java 23 feature, simplifies concurrent programming by allowing many tasks to run simultaneously without complex thread management. Additionally, the new foreign function and memory API enhances how Java interacts with native code and memory, providing more flexibility and improving overall performance. Next, let's look at some interesting facts about Java. One key advantage of Java is platform independence. Thanks to the JVM that executes Java bytecode, Java can run on any platform, making it suitable for many applications. Secondly, Java is used everywhere, from large enterprises to small startups, and powers some of the world's biggest organizations like LinkedIn and eBay. Finally, Java's backwards compatibility ensures that programs written in older versions usually run seamlessly on newer ones, making it a reliable choice for long-term projects. Java offers great career opportunities as many companies seek skilled developers. With a strong community, finding tutorials, forums, and resources to help you learn is easy. Java is also versatile, supporting web, mobile, and enterprise applications, and learning it provides a strong foundation for coding and understanding other programming languages. In this video, you learned that Java is a versatile programming language used in web apps, mobile apps, and enterprise software. It runs on any platform without modification. Its large developer community and backward compatibility make Java a reliable and widely adopted language. Welcome to this video about the Java ecosystem. After watching this video, you'll be able to describe the Java ecosystem and explain its components. Java is a prominent programming language pivotal in software development. It was created by Sun Microsystems in 1995 and is now owned by Oracle Corporation. The Java ecosystem comprises various tools, libraries, frameworks, and platforms that allow developers to create robust, scalable, and secure applications. Let's begin by exploring the core components of the Java ecosystem. The Java Development Kit, or JDK, is the primary toolkit for Java developers. It consists of three key elements. The Java Compiler, or Java-C, converts Java source code into platform-independent bytecode. The Java Runtime Environment, or JRE, which encompasses the Java Virtual Machine, or JVM, and core libraries, is required for running Java applications. Utilities refer to command line tools that assist in the development process. The JRE provides the necessary components for executing Java applications. These applications include the JVM, which executes bytecode and ensures platform independence, and the core libraries, which are essential APIs for various functionalities such as input-output, networking, and concurrency. To make programming in Java easier, many developers use integrated development environments or IDEs. An IDE is a software application that provides comprehensive facilities to programmers for software development. Here are some popular IDEs for Java. Eclipse is an open-source IDE known for its powerful plugins. IntelliJ IDEA offers smart code completion and various other features. NetBeans is an open-source IDE that is easy to use for beginners with a straightforward interface. IDEs typically include features such as code editor, debugger, build automation tools, and project management capabilities. Frameworks in the Java ecosystem facilitate code reuse and accelerate development. Let's look at the different types of frameworks. The Spring Framework is a comprehensive framework for enterprise applications featuring dependency injection or DI, which promotes loosely coupled code, aspect-oriented programming or AOP, which separates cross-cutting concerns from business logic, Spring Boot, which simplifies Spring application setup with embedded servers and pre-configured settings, and Spring Model View Controller or MVC, which streamlines web application development through a structured architecture. Hibernate is an object relational mapping or ORM framework that simplifies data handling by automating the mapping of Java objects to database tables. Build tools automate compiling code, managing dependencies, and packaging applications. Maven simplifies project management with features such as dependency management and a standardized build lifecycle. Gradle is known for incremental builds and multi-project support using Groovy or Kotlin for build scripts. Application servers provide environments for deploying and managing Java applications. Apache Tomcat is an open-source serverlet container ideal for small to medium-sized web applications. JBoss supports the full Java EE stack, suitable for large-scale enterprise applications. Testing frameworks ensures application functionality through robust testing tools. JUnit is used for creating repeatable tests using annotations and assertions to validate outcomes. TestNG offers additional features such as data-driven testing and parallel test execution. The Java ecosystem also supports cloud-native and microservices-based development. For example, Spring Cloud provides tools for building cloud-native applications, including service discovery and configuration management. Let's look at how the Java ecosystem works for desktop, mobile, and embedded development. Java for desktop applications uses certain key technologies. JavaFX is used for building rich desktop applications with modern user interfaces. JavaFX supports various graphical elements such as buttons, tables, and charts, making it easy to create visually appealing applications. Swing is an older GUI toolkit that is still widely used for building desktop applications. Swing provides a set of components that are lightweight and can be customized easily. It allows developers to create traditional desktop applications that can run on any platform that supports Java. Java is also used for mobile applications. Android is the most widely used mobile operating system globally, and it heavily relies on Java. The Android Software Development Kit, or SDK, includes tools and libraries specifically designed for building Android applications. It provides developers with APIs to access device features such as cameras, GPS, and sensors. Android Studio is the official IDE for Android development. It offers features such as code editing, debugging, and performance tuning. Android Studio simplifies the process of building applications with its robust tools and templates. While Kotlin is the preferred language for Android development, Java remains a significant part of the ecosystem. Many Android libraries are written in Java, making it essential for developers to understand both languages. Embedded systems are specialized computing systems that perform dedicated functions within larger mechanical or electrical systems. Java is increasingly being used in this domain due to its portability and ease of use. The key technologies used are Java ME and Embedded Java. Java Micro Edition, or ME, is a subset of the Java platform designed for developing applications on resource-constrained devices such as embedded systems. It provides a collection of APIs tailored for mobile and embedded environments. Embedded Java includes Java platforms specifically designed for embedded hardware. Implementations such as Oracle's Java Embedded allow you to run Java applications on devices such as sensors, gateways, and other embedded systems. The Java ecosystem is sustained successfully with the help of the community and support available in various forms. Online forums, such as Stack Overflow, allow you to ask questions and get answers from experienced developers. The official Oracle documentation provides detailed information about all aspects of Java. Attending local meetups or conferences can help you connect with other developers and learn new skills. In this video, you learned that the Java ecosystem comprises various tools, libraries, frameworks, and platforms. The JDK serves as the primary toolkit for Java developers. The JRE provides the necessary components for executing Java applications. An IDE is a software application that provides comprehensive facilities to programmers for software development. Frameworks facilitate code reuse and accelerate development. Build tools automate compiling code, managing dependencies, and packing applications. Application servers provide environments for deploying and managing Java applications. Testing frameworks ensure application functionality through robust testing tools. The Java ecosystem supports cloud-native and microservices-based development. It also supports desktop and mobile applications and development frameworks using certain key technologies. Welcome to this video on Java Virtual Machine Development Kit and Runtime Environment. After watching this video, you'll be able to explain the roles of the three primary components in Java in development and identify where they are used in developing or running Java applications. Java is one of the most popular programming languages in the world. It is used to power everything from web applications to mobile devices. What makes Java so versatile? The answer lies in Java Virtual Machine or JVM, Java Development Kit or JDK, and Java Runtime Environment or JRE, three components of Java. Let's explore these components. Java Virtual Machine or JVM is crucial in making Java platforms independent. It's an abstract machine that allows a computer to run Java programs. When a Java program is written, it gets compiled into a format called Java bytecode. The JVM converts this bytecode into machine code that the operating system can understand. This process is called just-in-time or JIT compilation. Additionally, JVM manages memory through garbage collection. This automatically frees up memory that's no longer in use, helping to prevent memory leaks and keep programs running smoothly. Imagine writing a letter in English to someone who only understands Spanish. The recipient needs a translator. The JVM acts as a translator between humans and machines, converting Java bytecode into machine code that the operating system can understand. Next, let's dive into JDK. A Java Development Kit, or JDK, is an essential software package that provides everything needed to build, compile, and run Java applications. The JDK includes the Java Runtime Environment, or JRE, which is necessary to execute Java programs along with development tools such as the JAVIC compiler, debuggers, and other utilities required for Java development. It also contains Java APIs, which are collections of libraries offering reusable code for common programming tasks. When a Java program is written, it is saved to a .java file. To run the program, it must be compiled into bytecode using the JAVIC compiler within the JDK. Once compiled, the bytecode is executed using the JVM, ensuring the program can run on any platform. The JDK can be compared to a complete toolbox for a carpenter. Just as a carpenter relies on various tools to build different types of furniture, developers use the JDK to create a wide range of Java applications, from simple programs to more complex systems. Java Runtime Environment, or JRE, provides the essential environment for Java programmers. It includes the JVM, core libraries, and other components required to execute Java applications. However, it does not contain development tools such as compilers for creating Java programs. When running a Java application, the JRE manages the loading of class files and executes them via the JVM. With the JRE installed, any Java programs can be run without needing the full JDK. An analogy for the JRE is a fully furnished room, ready for someone to live in. It contains everything needed to function comfortably, such as the JVM and libraries. However, if there is a need to build or renovate the room, the tools required for such tasks are not found in the JRE. These tools are a part of the JDK. Understanding the relationship between the JVM, JRE, and JDK is crucial for anyone working with Java. The JVM is the engine that executes Java bytecode and is part of the JDK and the JRE. The JRE package provides the libraries and components necessary to run Java applications, including the JVM but not the development tools. The JDK is the complete kit for developing Java applications, containing the JRE and development tools. The JDK is used when developing Java applications as it contains all the tools needed for coding, compiling, and debugging. The JRE is used when you want to run Java applications without developing them, as it is lighter and doesn't include development tools. The JVM, included in the JDK and JRE, runs Java programs by converting bytecode into machine code. The latest stable version of JDK, Java 23, was released in September 2024. The JDK and JRE are usually updated together. Therefore, the JRE for Java 23 is aligned with the JDK version, providing the necessary tools and security features to run Java applications. The Java Virtual Machine, JVM, which is part of both the JDK and JRE, also follows the Java 23 version. JVM updates are included in quarterly and critical patch updates from Oracle. Java is constantly updated, and you could be using a different version shortly. In this video, you learned that the JVM converts Java bytecode into machine code, making Java platform independent, and manages memory through garbage collection. The JDK contains the JRE and development tools, and it is used for building, compiling, and running Java applications. The JRE provides the environment to run Java applications, including the JVM and core libraries, but lacks development tools such as compilers. Welcome to this video on key Java features. After watching this video, you'll be able to list the key features of Java and explain their role in making the language versatile, secure, and efficient. Java is like a well-paved road, catering to novice and experienced drivers. Just as a smooth, well-constructed road makes the journey easier and more efficient for anyone, regardless of skill level, Java's design principles and features offer a straightforward path for beginners to get started while providing seasoned developers the flexibility and power to tackle more complex tasks. Let's explore these features. Java is a programming language that uses objects to represent real things. A class is a set of instructions that defines what an object belonging to a class or category should have and what it can do. For example, a class known as cars might define properties such as color, speed, and model, and actions such as accelerating, turning, or stopping. A specific car, such as a red Toyota Corolla, is an object created from the class called cars. Inheritance allows one object to take features from another. For instance, a car class can inherit features from a broader vehicle class, such as having wheels or an engine. Polymorphism means the same action can work differently depending on the object. For example, the start command could start a car's engine and turn on a boat's motor, even though the objects are different. Encapsulation keeps certain details private so that they can only be changed safely. For instance, a car's engine number is kept private so it can only be changed by authorized people or methods, preventing tampering. Another feature of Java is platform independence, which is made possible by the Java Virtual Machine, or JVM. When compiled, Java code is converted into bytecode that can run on any system with a JVM. This means you can write your code on one platform, such as Windows, and run it on others, such as macOS or Linux, without needing to change anything. For example, if a developer creates an application on their Windows computer, users can run it on any operating system without altering the code. This flexibility makes Java ideal for cross-platform development. Java is the strongly typed language. This implies that every variable must be declared with a specific data type before use. This helps catch errors during compilation because each variable's data type is known up front. For example, if you declare a variable as an integer, you can't accidentally assign it a string value later in the code. This strictness ensures better code quality and helps reduce bugs, especially in large applications where managing data types can be tricky. Another feature of Java is automatic memory management through garbage collection. This means developers don't need to manage object memory manually. The JVM automatically detects when an object is no longer needed and frees up that memory, helping to prevent memory leaks. For example, suppose you create an object representing a user session but forget to remove it after the session ends. In that case, Java's garbage collector will eventually reclaim that memory once it determines the object is no longer in use. This process helps improve efficiency and reduces the risk of memory-related issues. Java also supports multi-threading, which allows multiple threads to run simultaneously within a program. This is important for creating efficient and responsive applications. For example, in an online banking application, one thread could handle user input while another processes transactions in the background. This way, users can continue interacting with the application without waiting for long processes, making the app smoother and faster. Java's comprehensive standard library offers many pre-built classes and methods for common tasks. This library includes tools for networking, data structures, file handling, and much more. For example, if you're developing a web application, you can use Java libraries to handle HTTP requests and responses without writing extensive code from scratch. This rich set of resources accelerates development and reduces the need to reinvent solutions for common problems. Java's key focus is security. Java provides built-in features such as bytecode verification and a security manager that checks permissions before executing operations to enable this. For example, when running Java applets in web browsers, the security manager prevents unauthorized access to files or network resources, safeguarding users from malicious code. Java is a versatile language used in various domains. Frameworks such as Spring are commonly used to build robust web applications in web development. Java is the primary language for creating Android apps and mobile development. Additionally, Java is widely employed in creating large-scale enterprise applications thanks to its scalability, reliability, and ability to handle complex systems efficiently. Now let's explore some of the latest Java trends. Java is increasingly used for cloud-native development and microservices, with frameworks such as Spring Boot and Quarkus gaining popularity. Serverless architecture, supported by platforms such as AWS, Lambda, and Google Cloud Functions for Java development, is gaining popularity. Due to its stability, Java remains a top choice for AI and machine learning. Libraries such as Deep Learning 4J and DJL enable the development of AI models. The Spring framework continues to evolve with updates such as Spring Boot 3.0 and Spring Native 6.0, improving native image generation, cloud-native features, and performance. Lastly, integrated development environments such as IntelliJ, IDEA, Eclipse, and VS Code are widely adopted for Java development, offering enhanced features and support. In this video, you learned that Java's key features are object-oriented programming, which organizes code into objects for better management, platform independent, which allows Java to run on any system with Java support, strong typing, which enforces strict type checks during compilation, automatic memory management, which handles memory allocation and garbage collection, multi-threading, which lets multiple processes run simultaneously, a comprehensive standard library, which provides built-in tools for common tasks, built-in security features, which protect against security risks, and versatility across domains, which makes Java suitable for web, mobile, and other applications. Welcome to this video about how to structure Java code and comments. After watching this video, you'll be able to explain the meaning of comments in Java. You will also be able to describe the code structure used in Java. Finally, you will be able to discuss best practices for beginners using Java. Let's begin by exploring what comments are in Java. Comments are notes in the code that are not executed by the program. They are meant for developers to explain, clarify, or annotate parts of the code. Using comments is a good practice as it helps you and others to understand your code better when revisiting it later. Java supports 3 types of comments. Single-line comments start with 2 / marks. Everything that follows the slash on that line is treated as a comment. In this example, you can see 2 / and the commentary. This is a single-line comment integer number equal to 10. Again, there are 2 / followed by the commentary. This variable stores the number 10. Multi-line comments start with a / and then an asterisk. The code ends with an asterisk and a /. They can span multiple lines. In this example, you first see a slash followed by an asterisk followed by the commentary text. This is a multi-line comment. It can explain a block of code or provide detailed information. The code ends with an asterisk and a /. You can also post multi-line comments after your code. In this example, you'll see the code integer sum equals 0 followed by a space. Then you will see the /, asterisk, and comment. This variable will hold the sum of numbers, followed by an asterisk and a / to end the multi-line comment. Developers use documentation comments to generate documentation using tools like JavaDoc. Documentation comments start with a single / followed by 2 asterisks. Then you'll enter an asterisk and a space at the start of each line before typing your comment code. In this example, you can see the / and 2 asterisks. On the next line, you can see an asterisk and the first comment. This method calculates the number of a square. On the second line, you'll again see an asterisk, and then you'll see, at parameter number, the number to be squared. On the next line, you'll again see an asterisk and the text, at return the square of the input number. The next line displays an asterisk and a / that ends the documentation code. After the asterisk / you can see the related Java code. Programmers use comments for several reasons. Comments enhance clarity as they explain complex logic, making it easier for others to understand the content. Comments help developers maintain code. When you or someone else revisits the code later to maintain existing code, comments aid understanding by providing context and reducing confusion. Finally, in team environments, comments enable collaboration by helping team members better understand each other's work. Next, let's understand packages in Java. Packages are used to group related classes and interfaces together. They help avoid naming conflicts and make it easier to manage large projects. To create a package, you use the package keyword at the top of your Java source file. This example demonstrates how to declare a package in Java and define a class within it. Here, the package name is com.example.myapp. It defines a public class named myClass. The public keyword means this class can be accessed from other packages. The double / is where you add the actual functionality or code for the class, such as methods and variables. The folder structure of your file system should match the package declaration. This example represents how Java organizes files in a project when using packages. /src is the root folder for the source code in your project. com.example.myapp is a directory structure that matches the package name. Each part of the package name corresponds to a folder. It is also important to note the source files and naming conventions followed in Java. Each public class should be in its own source file named exactly after the class with a .java extension. For example, if you have a class named book, the file should be named book.java. This is the book class, part of the com.example.library package. Inside this class, we have two pieces of information or attributes, title and author. There's also a constructor, a special method that helps create a new book. It takes the title and author as inputs and assigns them to a book. This class is a blueprint for creating book objects in a library system. In Java, everything is organized into classes. A class is a blueprint for creating objects and can contain methods or functions that define behaviors. For instance, in a shopping application, you might have a product class with methods like calculate price or apply discount. In this example, the code defines a book class inside the com.example.library package. Package com.example.library declares the package name where this class belongs. Public class book defines a public class named book. String title and string author are instance variables or attributes to store the title and author of a book. Methods are used to encapsulate functionality within a class. They should have descriptive names and follow a consistent naming convention. One such example is camel case, wherein the first word is lowercase and subsequent words start with an uppercase letter. It is commonly used for variable and method names in Java. Every Java application needs an entry point, which is typically a main method within a public class. In this example, the code defines a main class in the com.example.library package with a main method to test the library system. The code library equals new library creates a new library object to store books. Library.addBook, new book, adds books to the library by creating book objects such as 1984 by George Orwell. Library.displayBooks displays all the books in the library by calling the displayBooks method. This code initializes a library, adds 2 books to it, and prints the list of books. It demonstrates object creation and method calls in a structured way. When you need to use classes from other packages, you need to import them at the top of your source file. Here is an example. First, you import tools from Java's built-in library. Import java.util.list, lets you use the list interface to handle collections of items. Import java.util.ArrayList, allows you to create a dynamic list using the ArrayList class. Next, you declare the package. Package com.example.library organizes the code and places the library class inside the com.example.library package. Finally, you define the library class. It's a public class where all the library-related code will go, such as storing and managing books. If you're just starting out using comments and structuring Java code, here are some best practices that can help you. Use meaningful and descriptive names for your classes, methods, and variables. A class named Customer is immediately understandable compared to a class named C1. Meaningful names make it easier for anyone reading your code to understand its purpose. Keep your code organized by managing a logical structure in your codebase. Group related classes into packages and keep your folder structure intuitive. For instance, if you have different modules for user authentication and product management, create separate folders for each module. Comment generously but wisely to explain why certain decisions were made in your code, especially if they are not immediately obvious. Avoid stating the obvious. For example, instead of saying // incrementing I by 1, just write I++, focusing on providing context rather than repeating what the code already shows. Adhere to consistent formatting throughout your code. This includes indentation, spacing, and braces placement. Most coding environments have settings that can help enforce consistent formatting automatically. Follow the flow of code execution. The flow of execution in Java follows a top-to-bottom approach within methods. When a program is run, the JVM starts executing from the main method of the class specified as the entry point. Understanding this flow helps in structuring your methods logically. In this video, you learned that comments in Java are notes in the code that are not executed by the program. The three types of comments are single-line, multi-line, and documentation. Comments help with clarity, maintenance, and collaboration. Packages are used to group related classes and interfaces together. Each public class should be in its own source file, named exactly after the class. In Java, a class is a blueprint for creating objects and can contain methods that define behaviors. Every Java application has an entry point, which is a main method within a public class. When you need to use classes from other packages, you can import them at the top of your source file. Finally, you learned that some best practices for a beginner are use meaningful names, keep your code organized, comment generously but wisely, follow consistent formatting, and use the flow of code execution. Welcome to this video about exploring data types in Java. After watching this video about exploring data types in Java, you'll be able to define what data types are, explain the purpose of data types, discuss primitive data types in Java applications, and describe available reference data types in Java applications. Every developer must understand data types. Think of data types as containers, each designed to hold specific types of information. For example, you wouldn't store soup in a shopping bag or groceries in a drinking glass. In programming, each data type specifies the type of data a variable can store and has specific properties such as size and range. They determine what operations Java programs can perform on the data. In Java, data types can be broadly categorized into two groups: primitive data types and reference data types. Let's compare these two data types. Let's begin with primitive data types. When you use a primitive data type, you specify the data type's stored value. Primitive data types consist of a fixed size and a default fixed immutable value, such as a specific integer or a yes or no value. Finally, primitive data types cannot contain a null value. Next, let's explore some primitive data types. Let's begin with the byte data type. A byte data type saves memory in large arrays for values between -128 and 127. For instance, byte age equals 25. You can use the data type to represent a person's age. The short data type is ideal for small integers ranging from -32,768 to 32,767. Use this data type for values like temperature, such as -5 degrees. The int data type is the most used integer data type suitable for larger whole numbers, such as populations. For example, an int population equals 1 million. The long data type handles very large integers that exceed the numbers available for int, such as the moon's distance in meters. For instance, long distance to moon equals 384,400,000 L. The float data type stores decimal numbers with up to 7 decimal places when high precision isn't needed. Use it for prices like float price equals 19.99F. The double data type provides greater precision for decimal numbers with up to 15 decimal places. One example is double pi, which equals 3.1415926535899793. The char type stores a single character, perhaps used as an on-screen selection option, such as char initial equals A. The Boolean type represents true-false values, often for conditions such as checking a user's login status. For example, you can have a Boolean is logged in equals true. Next, let's explore reference data types. Java programs use reference data types to locate objects or collections of data. Using reference data enables you to work with more complex data structures like text and lists. Next, learn about some reference data types. Let's begin with the strings data type. Strings are sequences of characters. You can think of a string as a line of text, such as a name, a message, or any combination of letters and numbers. Strings are very useful for handling text in your programs. An example of a string is the phrase "Hello World." Next, learn about the array data type. An array is a collection of multiple values stored under a single variable name. All the values in an array must be of the same type. Arrays are great for storing lists of items like student scores or names. This example creates an array called scores that holds 4 integer values. You can access each value using its index position in the array. Remember that indexing starts at 0. Classes are another reference data type. A class is like a blueprint for creating objects. Classes are useful for organizing related data and functions together, creating templates for multiple smaller items, and enforcing consistent structure behavior. An object is an instance of a class that contains both data, attributes, and methods functions to operate on that data. You can create your own data types using classes to model real-world things. Objects are useful for providing blueprints for classes, enabling a class to use features from multiple sources, enabling the use of multiple classes from one interface, and easing maintenance. An interface data type in Java is like a contract that defines a set of methods that a class must implement. When you create an interface, you only declare the methods without providing their actual code. All methods in an interface are empty by default. Interfaces act like a blueprint that tells classes what methods to use. They let a class use features from multiple sources, and you can use different classes in the same way if the classes follow the same interface. Using interfaces, your code becomes cleaner and easier to update. Finally, enum, short for enumeration, is a special data type in Java that lets you define a list of named values. It is useful for representing fixed sets of options, such as days of the week or colors. Finally, let's look at some best practices for selecting data types. When selecting data types for your programs, consider the following recommendations. The int data type works well for whole numbers. The double data type works well for decimal-based numbers. Use the string data type for text-based data. For yes and no conditions, use the Boolean data type. Be careful when working with decimal calculations. For example, you can use the double data type for when the wallet, coffee, and the amount calculations use the double data type. However, you'll see that the final monetary number is displayed using the float data type. Let's summarize what you've learned. In this video, you learned that data types are containers designed to hold specific types of information. Each data type specifies the type of data a variable can store and has specific properties such as size and range, which determine what operations Java programs can perform on that data. Primitive data types consist of a fixed size and a default immutable value. Primitive data types include byte, short, int, long, float, double, char, and boolean. Reference data types use a memory address that finds the actual data's location. Reference data types enable the use of more complex data structures, including texts and lists. Reference data types include strings, arrays, classes, interfaces, and enums. Welcome to this video that introduces you to operators in Java. After watching this video, you will be able to define operators in Java. You will also be able to describe some of the basic operators and explain how they work. When you write programs in Java, you often need to perform different types of operations on your data, such as adding numbers, comparing values, or combining conditions. This is where operators come in. Operators are special symbols that perform operations on variables and values. They tell the Java compiler to perform specific mathematical or logical manipulations. Operators can work with variables, constants, and expressions to produce the expected result. Here's an example where the plus operator adds the values of a and b. Integer a equals 10 assigns the value 10 to the variable a. Integer b equals 5 assigns the value 5 to the variable b. Integer sum equals a plus b calculates the sum of a and b, storing the result 15 in the variable sum. Java has several types of operators. Let's explore them. Arithmetic operators are used to perform basic arithmetic operations. Let's go over them. The addition operator, written as a plus sign, adds two values. For example, a plus b adds a and b. The subtraction operator, written as a minus sign, subtracts one value from another. Example, a minus b subtracts b from a. The multiplication operator, represented by an asterisk, multiplies two values. For example, A asterisk B multiplies A and B. The division operator, written as a / divides one value by another. For example, A / B divides A by B. Finally, the modulus operator, written as a percentage sign, gives the remainder when one value is divided by another. For example, A percentage B finds the remainder of A divided by B. These operators are the foundation of basic calculation in Java. In this example, you can see two numbers, A equals 10 and B equals 5, to demonstrate basic math operations in Java step by step. The code calculates A plus B, which gives 15, and prints addition 15. Next, the code calculates A minus B, which equals 5, and prints subtraction 5. By multiplying A and B, you get 50, and it prints multiplication 50. When dividing A by B, the result is 2, so it prints division 2. Finally, the modulus operator A percentage B finds the remainder when A is divided by B and prints modulus 0. Relational operators are used to compare two values. They return a Boolean result, true or false. Equal to, symbolized by 2 equals 2 signs, checks if two values are the same. For example, A equals B is true if A and B are equal. Not equal to shows an exclamation mark, and an equal to sign checks if the two values are different. For example, A exclamation equals B is true if A and B are not the same. Greater than checks if one value is larger than the other. For example, A is greater than B is true if A is greater than B. Less than checks if one value is smaller than the other. For example, A less than B is true if A is less than B. Greater than or equals to checks if one value is larger than or equal to the other. For example, A is greater than or equal to B is true if A is greater than or equal to B. Less than or equal to checks if one value is smaller than or equal to the other. For example, A less than equal to B is true if A is less than or equal to B. Here's an example. Let's start with A equals 10 and B equals 5. The first line checks if A is equal to B. Since 10 is not equal to 5, it prints, is A equal to B? False. The second line checks if A is not equal to B. Since 10 is different from 5, it prints, is A not equal to B? True. The third line checks if A is greater than B. Since 10 is greater than 5, it prints, is A greater than B? True. The fourth line checks if A is less than or equal to B. Since 10 is not less than or equal to 5, it prints, is A less than or equal to B? False. This is how relational operators compare numbers and make decisions in a program. Logical operators are used to combine multiple Boolean expressions. Let's look at some basic logical operators in Java. Logical AND, written as two ampersands, checks if both conditions are true. For example, in A is greater than B and B is less than C, the result is true only if A is greater than B and B is less than C. Logical NOT, written as an exclamation mark, reverses a condition's result. For example, exclamation A greater than B means, is it not true that A is greater than B? If A is not greater than B, the result will be true. These operators help to combine or negate conditions in your code. This example uses Boolean values where true means yes and false means no. Here, X is true and Y is false. Next, let's apply some logical operators. In the first instance, the result is true only if both X and Y are true. Here, X and Y give false because Y is false. In the second instance, the result is true if X or Y are true. Here, X or Y gives true because X is true. The final instance flips the value of X, so exclamation X turns true into false. In this video, you learned that operators are special symbols that tell the Java compiler to perform specific mathematical or logical manipulations. There can be different types of basic operators. Arithmetic operators are used to perform basic arithmetic operations. Relational operators are used to compare two values. Logical operators are used to combine multiple Boolean expressions. Welcome to this video about how to use advanced operators in Java. After watching this video, you'll be able to describe the different types of advanced operators and explain how they work. Advanced operators, such as bitwise and shift operators in Java, go beyond basic arithmetic, comparison, and logical operators. They are primarily used for low-level programming tasks, such as optimizing performance or working with hardware. They can also be used for graphics programming, cryptography, and so on. Bitwise operators are used for working with binary data, and shift operators are for shifting bits in numbers. Assignment operators are used to assign values to variables. Let's go over some common assignment operators in Java. The equal symbol assigns a value to a variable. For example, a equals 10. The add and equal symbol adds a value to a variable and updates it. For example, a plus equals 5. The subtract and equal symbol subtracts a value and updates the variable. For example, a minus equals 2. The multiply and equal symbol multiplies the variable by a value and updates it. For example, a asterisk equals 3. The divide and equal symbol divides the variable by a value and updates it. For example, a / equals 2. The modulus and equal symbol finds the remainder when the variable is divided and updates it. For example, a percentage equals 4. These operators combine a math operation with an assignment, making the code shorter and easier to write. In this example, compound assignment operators update the value of the variable a. Start with a equals 10. Then a plus equals 5 adds 5 to the value of a. So now a equals 10 plus 5, which is 15. The program prints new value of a, 15. Next, an asterisk equals 2 multiplies a by 2. So now a equals 15 asterisk 2, which is 30. The program prints, after multiplication, new value of a, 30. This is how you can perform addition and multiplication directly on a variable while updating its value. Unary operators operate on a single operand. They can be used for incrementing, decrementing, or negating values. Let's explore some unary operators in Java. Unary plus doesn't change the value, but it sometimes is used for clarity. For example, plus a simply means the value of a. Unary minus the sign of a value. For example, if a equals 5, then minus a becomes minus 5. Increment adds 1 to the variable. Decrement subtracts 1 from the variable. Here's an example. Suppose you have a equals 10. Using the plus sign with a, as in plus a, keeps the value the same. So it prints unary plus 10. Using the minus sign flips the sign of a. So minus a becomes minus 10, and it prints unary minus minus 10. Increment adds 1 to a. After incrementing, a becomes 11, and it prints after increment 11. Decrement subtracts 1 from a. After decrementing, a goes back to 10, and it prints after decrement 10. This is how unary operators can flip a number's sign or increase and decrease its value. The ternary operator is a shorthand form of the conditional statement. It takes 3 operands. This is the syntax for a ternary operator in Java, which is like a shortcut for an if-else statement. How it works. First, write a condition. If the condition is true, it executes expression 1. If the condition is false, it executes expression 2. In this example, you use the ternary operator to find the larger of 2 numbers. There are 2 numbers, a equals 10 and b equals 20. The line, if a is greater than b, then a otherwise b, checks if a is greater than b. If the condition a is greater than b is true, it assigns the value of a to max. If the condition is false, it assigns the value of b to max. Since a is not greater than b, the value of b, which is 20, is assigned to max. Finally, the program prints maximum value is 20. In this video, you learned that advanced operators are bitwise operators that work with binary data and shift operators that shift bits and numbers. They can be of different types. Assignment operators are used to assign values to variables. Unary operators operate on a single operand and can be used for incrementing, decrementing, or negating values. The ternary operator is a shorthand form of the conditional statement. Welcome to this video about working with arrays in Java. After watching this video, you will be able to define what an array is as used in Java, describe how to declare, create, and modify an array, and explain how to iterate through arrays. Arrays are one of the fundamental Java data structures and many other programming languages. Arrays allow you to store multiple values in a single variable, making it easier to manage collections of data. Worded another way, an array is a collection of elements, all of the same type, which are stored in contiguous memory locations. Each element in an array can be accessed using an index, which is a numerical representation of the element's position within the array. In Java, arrays can hold primitive data types such as int, char, or boolean, or reference types such as objects. To declare an array in Java, use the following syntax. Data type opening square and closing bracket space array name semicolon. For example, if you want to declare an array of integers, you would type int open square bracket, closing square bracket, base number semicolon. After you declare an array, you need to initialize the array to allocate memory to the array. You can accomplish this task by adding the keyword new. Here's how to create and initialize an array of 5 integers. Use the code numbers equal new int open square bracket 5 closing square bracket semicolon. You can also declare and initialize an array in a single line. Notice the keyword new. Alternatively, you can create an array and assign values using curly braces. You can access individual elements in an array by specifying the index inside square brackets. Remember that indices start at 0. In the first example, the first index for the number is set to 0, which provides an output of 1. In the second example, the specified index is 4, which provides an output of 5. Next, learn about modifying array element values and changing an array's length. You can change the value of an array element by accessing its index. You'll change the value of the array element numbers open square bracket to closing square bracket equals 10. You change the third element to the number 10. To determine how many elements are in an array, you can use the length property that you see when you run the system.out.println code, and it reports the number's .length. A common operation with arrays is iterating through them to read or modify their elements. You can use a for loop for this purpose. Here's an example that prints all elements in the numbers array. When the integer I equals or exceeds the array length, the loop stops. After each iteration, the I++ code increments I by 1, moving to the next array element. You can also use the enhanced for loop, also known as the for each loop. Java supports multi-dimensional arrays, which are essentially arrays of arrays. The most common type is the two-dimensional array. Here's how to declare and initialize a 2D array. The code int left square bracket right square bracket left square bracket right square bracket matrix equals curly open brace creates a variable named matrix that can hold whole numbers arranged in this grid pattern. The double square brackets tell Java that you want a 2D array, a grid, instead of a single line of numbers. The name matrix is the grid's name. The numbers inside the curly braces are the actual values that are part of the grid. Each inner set of curly braces represents one row of the grid. So when you write opening curly brace 1, 2, 3 closing curly brace, opening curly brace 4, 5, 6 closing curly brace, opening curly brace 7, 8, 9 closing curly brace, you're creating a 3x3 grid. When you want to retrieve a number from this grid, you'll need to specify which row and column you want, just like giving coordinates on a map. Next, you can access elements in a two-dimensional array by specifying the matrix for both indices. You can access elements of a two-dimensional array by specifying both indices as here, where you specify matrix array and index 0 by index 1. You can use nested loops to iterate through all elements of a 2D array. In this instance, the code reads each for loop and then follows the system print instructions. The code for int I equals 0 semicolon I less than matrix dot length semicolon I plus plus opening curly brace creates the outer loop that handles each row. The second line, which reads for int j equals 0 semicolon j less than matrix opening square bracket I closing square bracket dot length semicolon j plus plus opening curly brace. This code creates the inner loop that handles each column in the current row. The next line reads system.out.print opening parentheses matrix square bracket I closing square bracket j closing square bracket plus quote space quote closing parentheses semicolon. This prints each number in the grid with a space after it. Finally, system.out.println opening parentheses closing parentheses semicolon moves the program to a new line after printing each row. Together, these loops walk through the grid row by row, printing each number until the entire grid is displayed. In this video, you learned that an array is a collection of elements, all the same type, which are stored in contiguous memory locations. To declare an array, write the data type followed by square brackets, and then add a space and the array name with a semicolon at the end. Initialize an array to allocate memory to the array. Initialize an array by adding the keyword new. Specify the index inside square brackets to access individual elements in an array. You can use for loops, either singular or nested, to iterate through arrays to read or modify their elements, and you can use nested loops to iterate through all elements of a 2D array. Welcome to this video about conditional statements in Java. After watching this video, you'll be able to define what conditional statements are, explain the purpose of conditional statements, apply if-else, and else-if statements in Java, use the switch statement, describe when to use the default case, and implement nested conditional statements in Java applications. Conditional statements are an important programming construct. In Java, conditional statements result in decisions that direct your program to act based on the specified conditions. Think of conditional statements as questions that your program asks while running. You direct the program's next actions based on the answer to those questions, such as true or false. Java uses several conditional statements, including the if statement, the if-else statement, the else-if statement, and the switch statement. Let's explore how you can use each of these statements. The if statement checks for a specific condition. If the condition is true, the program runs the code inside the statement. In this example, this code displays an integer number equal to 10. The code contains a conditional statement that reads, if number greater than sign 5, and checks if the number is greater than 5. Because the number 10 is greater than 5, the program follows the code instructions of system.out.println, and prints the statement that the number is greater than 5. Next, the if-else statement gives an alternative action if a condition is false. You would use this conditional statement to run the code inside the statement if the condition is false. In this example, the code displays an integer number equal to 3. The code contains a conditional statement that reads, if number greater than sign 5, and checks if the number is greater than 5, and uses the code else system.out.println the number is greater than 5 to print a statement confirming that the number is greater than 5 if that statement is true. The next line of the code displays the else condition, which reads as else system.out.println the number is not greater than 5. Because the number 3 is less than 5, the program follows the code instructions of else conditional statement and prints the statement the number is not greater than 5. Next, let's check out the else-if statement. You can check multiple conditions by including the else-if in a code block. For example, the following program has an integer variable called number with the value of 5. The program uses the if, else-if, and else statements. For the first if condition, the program asks, is the number greater than 5? If the variable number is true, the program uses the system.out.println statement to print, the number is greater than 5. If the condition is false, such as if the number equals 5, the program skips printing and moves to the next condition. The else-if condition asks, is the number equal to 5? If this condition is true, the program prints the number equals 5. If the condition is false, the program skips this part of the code and moves to the final condition. If the program gets to the final else condition, and if neither of the earlier conditions are true, the program prints the number is less than 5. In this instance, the integer meets the second condition, and the program ends with the second condition. A switch statement checks a single variable against multiple values. Compared to writing many if-else statements, the switch statement helps you cleanly manage multiple conditions for a single variable. In this program, you can use a switch statement to check the value of the variable named day. Each case represents a day of the week, such as case 1 for Monday, case 2 for Tuesday, and so on. If no cases match, the default case runs, printing weekend. Here, since day equals 3, which matches case 3, the program outputs Wednesday. When using a switch statement, it's good practice to include a default case, which runs if none of the specified classes match, acting as a fallback option. You can nest conditional statements for complex decisions. For example, this code uses nested if statements to handle multiple conditions. First, the code uses an if statement to check if the age is 18 or older. If true, the program prints, you are an adult. Inside this block, the code nests another if statement, checks if the age is 65 or older, and prints, you are a senior citizen. If the first condition is false, the program prints you are a minor. Since the age is 20, the program prints you are an adult. The second message does not print because 20 is not greater than or equal to 65. Now let's recap what you've learned. In this video, you learned that in Java, conditional statements result in decisions that direct your program to act based on the specified conditions. Conditional statements result in decisions that direct your program to act based on the specified conditions. The if statement checks for a specific condition and runs the program's code inside the statement if that condition is true. The if-else statement gives an alternative action if a condition is false. A switch statement checks a single variable against multiple values, and you can nest conditional statements for more complex decisions. Welcome to this video that introduces you to loops in Java. After watching this video, you'll be able to define loops in Java and explain why they are used. You will also be able to describe the different types of loops. Imagine you need to print the numbers from 1 to 10. Instead of writing 10 separate print statements, you can use a loop to accomplish this task with just a few lines of code. Loops are fundamental programming constructs that allow you to execute a block of code repeatedly based on a condition. In Java, loops help you perform repetitive tasks efficiently. Loops make your code shorter, cleaner, and easier to manage. Java provides 3 primary types of loops: for loop, while loop, and do-while loop. The for loop is used when the number of iterations is known beforehand and consists of 3 parts. Initialization sets a counter variable. Condition checks that the loop should continue executing. Increment or decrement updates the counter variable after each iteration. In the syntax shown here, the code inside the curly braces is what gets repeated during each loop. Let's say you want to print the numbers from 1 to 5. This code shows a for loop in action counting from 1 to 5. You start with the class named forLoopExample and the main method where the program begins. In this example, initialization starts the counter at 1. The condition I is less than or equal to 5 checks if I is less than or equal to 5. The increment I++ increases I by 1 after each iteration. When you run this code, the output is numbers 1 to 5. The while loop is used when the number of iterations is not known in advance. It continues executing as long as the specified condition remains true. The syntax for while loop is displayed here. The loop first checks the condition inside these parentheses. If the condition is true, it runs the code inside the curly braces. After running the code, it checks the condition again. The loop continues until the condition becomes false. Suppose you want to print numbers from 1 to 5 using a while loop. In this example, initialization starts the counter at 1. The condition I is less than or equal to 5 checks if I is less than or equal to 5. After printing I, you increment it by 1. The loop continues until I exceeds 5. The output will be numbers 1 to 5. The do-while loop is similar to the while loop, but guarantees that the code block executes at least once before checking the condition. Here's how the syntax for the do-while loop works. The code inside the curly braces is executed first, no matter what. Then the condition inside the parentheses is checked. If the condition is true, the loop runs again. This process repeats until the condition becomes false. Let's modify the previous example to use a do-while loop. Initialization starts the counter at 1. The do block runs the code inside at least once and prints the value of I. I++ increases I by 1 after each print. The condition or the loop checks while, that is, if I is less than or equal to 5. If true, it keeps running. If false, it stops. Here too, you will see the output will be numbers 1 to 5. Even if the initial value of I were set to a number greater than 5, the loop would still execute once before checking the condition. You can also use loops inside other loops known as nested loops. This is useful for working with multidimensional data structures, such as arrays or matrices. Let's look at an example of nested loops. This instance demonstrates nested loops in Java by creating a multiplication table. The outer loop controls the rows, with I starting at 1 going up to 10. The inner loop handles the columns, with j also running from 1 to 10. Inside the inner loop, the product of I and j is calculated and printed, followed by a tab for spacing. After the inner loop finishes, the system.out.println command moves to the next line to start a new row. The result is a neatly formatted multiplication table from 1 to 10. The break statement is used to terminate a loop immediately, regardless of the loop's condition. This can be useful when you want to exit a loop based on a specific condition that may occur during its execution. The syntax is the commentary break followed by a semicolon. Let's say you want to find the first number that is greater than 5 in an array of integers. You can use the break statement to exit the loop as soon as you find it. So in this example, the loop iterates through the numbers array. As soon as the loop finds a number greater than 5, which is 7, it prints the number and exits the loop with the break statement. The continue statement is used to skip the current iteration of a loop and move to the next iteration. It's useful for when you want to skip certain conditions but continue executing the rest of the loop. The syntax is the commentary continue followed by a semicolon. Suppose you want to print all the numbers from 1 to 10, but you want to skip printing the number 5. When I equals 5, the continue statement is executed, skipping the system.out.println I command for that iteration. The output will be numbers 1 to 10. In this video, you learned that loops are fundamental programming constructs that allow you to execute a block of code repeatedly based on a condition. The for loop is used when the number of iterations is known beforehand. The while loop is used when the number of iterations is not known in advance. The do-while loop is similar to the while loop, but guarantees that the code block executes at least once before checking the condition. Nested loops are useful for working with multidimensional data structures. The break statement is used to terminate a loop early, regardless of the loop's condition. The continue statement is used to skip the current iteration of a loop and move to the next iteration. Welcome to this video on working with strings in Java. After watching this video, you'll be able to describe strings and explain common string operations. Imagine a bead necklace. Each bead represents a character, and the entire necklace represents the string. Just as you can count, remove, rearrange, and replace pearls on the necklace, you can manipulate characters in a string to get the requested result. A string is a sequence of characters, like a line of text in a book. They include spaces and punctuation. For example, Hello World is a string with 13 characters. Strings are essential in Java for handling text like names or messages. Let's explore some common string operations. Strings in Java can be created by enclosing text in double quotes as a string literal or by using the new keyword to create a string object. For example, you can simply write Hello World as a literal or use the keyword newString with the same text to explicitly create an object. The length method finds the number of characters in a string. It returns the total number of characters, including spaces. For example, the string Java programming has 18 characters. Use the char@at method to access individual characters from a string. This method returns the character at a specific position, starting from index 0. For example, in the string Java, calling char@0 gives the first character. Combining strings is known as concatenation. This operation can be executed with the plus operator or the concat method, both of which yield the same output. Comparing strings is done using the equals method, which checks if two strings have identical content. The equals method ensures that the actual characters in the strings match and is case sensitive. For example, if hello is compared to hello, it returns true. However, comparing hello to world returns false. Substrings within strings can be extracted using the substring method. It allows specifying at a starting and ending index. For example, the string Java programming, starting at index 5 and ending at index 16, extracts programming. The ending index is not included in the result. Strings can be split up using the split method, which breaks a string into smaller pieces based on a specified delimiter. For example, if a string contains data separated by commas, the split method can divide it into individual parts. In the case of the string apple, banana, cherry, splitting it at each comma results in an array with 3 elements. Similarly, joining strings can also be done using the string.join method. If there is an array of strings and the goal is to combine them into one single string, this method allows specifying a separator. For example, joining the strings red, green, and blue with a comma and space results in the string red, green, blue. Immutable means that once an object or value is created, it cannot be changed or modified. In Java, strings are immutable. If you try to modify it, a new string is created instead. For example, when hello is combined with world, a new string hello world is created rather than modifying the original string. Java has built-in methods for strings that help manipulate and process them. The toUpperCase method converts all letters in a string to uppercase, and the toLowerCase method converts all letters in a string to lowercase. The trim method removes any extra spaces at the beginning or end of a string. The replace method changes all instances of a character or substring to another. In this video, you learned that strings are sequences of characters, including spaces and punctuation. These strings can be created using string literals or the new keyword. The length method returns the number of characters in a string. The char@at method retrieves a character at a specific index. Strings can be concatenated using the plus operator or the concat method. The equals method compares two strings for identical content. The substring method extracts a part of a string. The split method divides a string into smaller pieces. The string.join method combines strings with a separator. Strings are immutable, meaning modifying them creates a new string. Finally, in Java, strings have several built-in methods. The toUpperCase method converts a string to uppercase, while the toLowerCase method converts it to lowercase. The trim method removes spaces at the beginning or end of a string, and the replace method replaces characters or substrings within a string. Welcome to this video on using packages and imports. After watching this video, you'll be able to describe packages and imports, explain the package creation and import process, and list important Java packages. Imagine entering a meticulously organized record office. Each department has its own labeled cabinets, and related files are neatly stored within each cabinet. Packages in Java act as these cabinets, organizing related classes and interfaces into specific namespaces. A package in Java serves as a namespace that organizes and groups related classes and interfaces. It facilitates efficient file management within a project, simplifying the development and maintenance of large-scale applications. Packages in Java help organize classes into a folder-like structure, making them easier to locate and use. They also prevent name conflicts by providing a unique namespace for each class, allowing classes with the same name to exist in different packages. Additionally, packages control access by allowing some classes to be public while restricting others to package-level visibility. To create a package in Java, add the package keyword at the top of your file, followed by the package name. If you wanted to create a package named com.example, add the package keyword at the top of your file, followed by the package name and a semicolon. To ensure uniqueness, use a reverse domain name as the package name. To create a package in Java, first declare it at the top of your Java file using the package keyword, followed by the package name such as package shapes. Next, define a class within the package. In this case, a class called circle. Inside the class, declare a private attribute called the radius, which will store the circle's radius. The constructor will initialize the radius attribute when creating a new circle object. Finally, implement the area method to calculate and return the area of the circle. Next, let's explore imports. An import is a statement in Java that allows users to bring in classes or packages into their current file, making the code cleaner and more readable. It eliminates the need to type the full package name each time a class is used. To import a class in Java, you need to use the import statement followed by the package name, a dot, and then the class name. For example, you would write shapes.circle to use the circle class from the shapes package. This tells Java to import the circle class so that you can use it in your code. Once you've imported it, you can create an object of the circle class and use its methods, such as performing actions with that class. You can import all classes from a package by using an asterisk. To import all classes in the shapes package, type import shapes followed by a dot and then an asterisk. This allows you to use any class in the shapes package without importing them individually. Java offers a range of built-in packages for various programming tasks. The java.lang package is automatically imported and provides core classes for Java development. Key classes in this package include string for text manipulation, math for mathematical functions, and system for input and output, and environment interaction. Next, the java.util package contains classes for collections, data structures, and algorithms. Key classes include ArrayList for resizable arrays, HashMap for data in key-value pairs, and Date for managing dates and times. The java.io package enables input and output operations, including file handling and stream processing. Key classes in this package are File, which manages file paths and directories, Input Stream and Output Stream for reading and writing byte streams, and Buffered Reader, which efficiently reads text from input streams. The java.net package offers classes for networking, allowing communication over networks and access to web resources. Key classes include Socket, which is used for client-server communication, and URL, which represents a web address for accessing resources. The java.sql package facilitates database connectivity and executing structured query language, or SQL queries. Key classes in this package are Connection, which establishes database connections, and Statement, which executes SQL commands. Lastly, the java.time package provides a modern API for handling dates and times. Key classes include local date, which manages dates without time zones, and local time, which handles times without dates. Keeping your Java project organized doesn't have to be hard. use a unique naming convention like your domain name in reverse, group related classes together, and keep package names short and clear to facilitate easy package management. Similarly, clean and efficient imports are critical in Java coding. Import only what you need instead of using wildcards. Organize imports logically for better readability, and remove unused imports to keep your code tidy and professional. In this video, you learned that a package in Java is a namespace that organizes related classes and interfaces into a structured folder-like format. Packages are created using the package keyword followed by the package name. An import in Java is a statement that allows a programmer to include classes or entire packages into their code. Imports in Java are done using the import keyword followed by the package or class name. Some common Java packages include java.lang, java.util, java.io, java.net, java.sql, and java.time. Welcome to this video on implementing functions and methods. After watching this video, you'll be able to describe functions, methods, and their classifications. You'll also be able to explain the process of creating functions and methods and differentiate between the two. Imagine a cookbook with countless recipes. Each recipe is like a function. It takes a specific ingredient as input, follows the steps outlined in the recipe as code, and produces a dish as the final output. A function is a block of code. It performs a specific task and helps organize, reuse, and improve the readability of code. In Java, a function is created using a specific structure that includes the return type, the function name, and optional parameters, followed by a code block. The return type indicates the type of value the function will return, such as int, double, or string. If no value is returned, the function is known as void. The function name describes its purpose, while parameters, if any, serve as the function's inputs, allowing data processing. The code block contains the logic to execute, and an optional return statement provides the function's output. Let's consider an instance where a simple function is created to add two numbers. The add function takes two integers, a and b, as parameters and returns their sum. In the main method, the add function is called with the values 5 and 3, and the result is stored in the variable called sum. Finally, the sum is printed using the system.out.println. Now let's explore methods in Java programming. To illustrate methods, let's consider an example where a method is created within a class. The multiply method belongs to the calculator class. In the main method, an instance of the calculator class is created to call the multiply method. A method is a function that is associated with a class. It defines the behavior or actions that objects of that class can perform. The process of creating a method is similar to creating a function. It includes defining the return type, method name, input parameters, and the code with an optional return statement. To illustrate methods, let's consider an example where a method is created within a class. The multiply method belongs to the calculator class. In the main method, an instance of the calculator class is created to call the multiply method. Now let us say a parameter is a variable used to define the input type of a function or method, while arguments are the actual values passed to a function or method when called. Let's consider an example with multiple parameters. In this example, the greet method takes two inputs, a string for the person's name and an int for the person's age. These inputs define what values the method expects. When the method is called in the main method, it receives the value Alice and 30. The method then uses these values to print a personalized greeting, "Hello Alice, you are 30 years old." A return value is the result that a function or method gives back after performing its task. It can be any data type, such as a number or a string, and is specified in the return statement. In this example, the area of a rectangle is calculated. In the main method, an instance of the rectangle class is created, and the area method is called with the values 4.5 and 3.0. The result is stored in the area variable, and the area of the rectangle is printed as the area of the rectangle is 13.5. Method overloading defines multiple methods with the same name in a class but with different parameters. The correct method is chosen based on the arguments passed when the method is called. Let us consider an instance where the display class has two show methods with different parameter types. The first show method takes an int as a parameter and prints the number, while the second takes a string and prints the text. In the main method, an instance of the display class is created, and both show methods are called with different arguments, one with the number 10 and the other with the text "Hello World." This demonstrates method overloading, where methods share the same name but have different parameter types. An identifier in Java is a name given to a variable, method, class, or entity. The scope of an identifier refers to where in the program it can be accessed. In Java, there are different types of scope. Local scope, where identifiers are accessible only within a method or block. Instance scope, where variables are declared in a class, but outside methods are accessible throughout the class. A static scope, where static variables belong to the class and are accessible throughout the class. A void method acts without returning a value. For example, the print message method prints hello world but returns nothing. In Java, a function is a standalone block of code that performs a specific task and can exist independently, although they are not commonly used in Java. Functions can take inputs, perform operations, and return values, but are not directly tied to a class or object. On the other hand, methods are functions associated with a class and operate on objects of that class. Methods are integral to object-oriented programming as they can access instance variables and other methods within the class, enabling them to interact with and modify the state of the objects. Methods play a central role in defining the behavior of objects in Java. In this video, you learned that a function is a standalone block of code that performs a specific task, while a method is a function associated with a class. Both functions and methods are created by defining a return type, name, parameters, and a code block. The key difference between the two is that methods are tied to classes and can access instance variables, whereas functions are independent and not tied to any class. Welcome to this video that introduces you to exceptions in Java. After watching this video, you'll be able to define exceptions in Java and describe different types of exceptions. You will also be able to explain how to handle exceptions. Java is a versatile programming language enabling the creation of robust applications. One of the key features of Java is its exception handling mechanism. An exception is an event that disrupts the normal flow of a program. It is an error that occurs during the execution of a program, which can cause it to behave unexpectedly or crash. Exceptions can arise from various situations, such as trying to divide by zero, accessing an invalid index in an array, or attempting to open a file that does not exist. Let's understand the role of exceptions in Java. Exceptions in Java provide a way to handle errors gracefully without crashing the program. Instead of letting the program terminate abruptly, you can catch these exceptions and take the appropriate actions, such as displaying error messages or attempting to recover from the error. Exceptions can occur for several reasons, including invalid user input, device malfunction, disruption of network connectivity, out-of-bounds access, null reference issues, type mismatches, attempting to open an unavailable file, database-related errors, and arithmetic mistakes. Just like exceptions, you also have something called errors. Errors signify serious conditions that cannot be recovered from. They are usually related to the environment in which the application is running. These errors typically lie outside of the programmer's control, and attempts to handle them should be avoided. Examples include Java Virtual Machine or JVM exhausting memory, memory leaks, stack overflow errors, library incompatibilities, infinite recursion, and more. It is important to understand the difference between errors and exceptions. An error catches a critical issue that a reasonable exception should not attempt to catch. On the other hand, an exception denotes situations that a reasonable application might try to catch. Exceptions can be of different types. Checked exceptions are exceptions that the compiler checks at compile time. You must handle these exceptions either with a try-catch block or declare them in the method signature using the throws keyword. Let's look at some examples. The I/O exception occurs when there is an input-output operation failure, such as reading from a file that doesn't exist. The SQL exception is related to database access errors, such as when executing SQL statements. The class not found exception is thrown when an application tries to load a class by its name but cannot find it. Unchecked exceptions are exceptions that are not checked by the compiler at compile time. They usually indicate programming errors and can be avoided by writing correct code. Here are some examples. The null pointer execution occurs when an application attempts to use a null object reference, such as calling a method on a null object. The array index out-of-bounds exception is thrown when trying to access an array with an index that is either negative or greater than or equal to the array's size. An arithmetic exception occurs when an exceptional arithmetic condition occurs, such as dividing by zero. Finally, the illegal argument exception is thrown to indicate that a method has been passed an illegal or inappropriate argument. Custom exceptions are when you create your own exception classes in Java by extending the exception class for checked exceptions or runtime exceptions for unchecked exceptions. This allows you to define specific error conditions relevant to your application. Java provides a robust mechanism for handling exceptions using the try, catch, and finally blocks. The try block contains code that might throw an exception during execution. The catch block handles the exception if it occurs. Multiple catch blocks can be used to handle different types of exceptions. The finally block contains code that will execute regardless of whether an exception occurred or not. It is often used for cleanup operations, such as closing files or releasing resources. Let's look at a simple example where we divide two numbers and handle the possibility of division by 0. In this example, you attempt to divide the numerator by the denominator. Since the denominator is 0, it throws an arithmetic exception. The catch block catches this exception and prints an error message. The finally block executes regardless of whether an exception occurred or not, ensuring that any necessary cleanup can happen. Sometimes you may want to create your own exception types. You can do this by extending the exception class. Here's how to create a custom exception. Create a custom exception class named myCustomException that extends exception. The constructor takes a string message and passes it to the superclass's constructor. In the main method, throw your custom exception and catch it in a catch block, printing the custom message. In this video, you learned that an exception is an event that disrupts the normal flow of a program. Exceptions provide a way to handle errors gracefully without crashing the program. An error signals a critical issue that a reasonable application should not attempt to catch as it lies outside the programmer's control. There are different types of exceptions in Java. Checked exceptions are exceptions that the compiler checks at compile time. Unchecked exceptions are exceptions that are not checked by the compiler at compile time. You can customize exception classes in Java by extending the exception class for checked exceptions or runtime exception for unchecked exceptions. Finally, you learned that Java provides a robust mechanism for handling exceptions using the try, catch, and finally blocks. Welcome to this video about how to use finally blocks in Java. After watching this video, you'll be able to describe the finally block in Java. You'll also be able to explain its correct and incorrect usage. One important feature of Java is its exception handling mechanisms, which include the try, catch, and finally blocks. Here you can see the structure of the exception handling mechanism. The try block contains code that might throw an exception. The catch block contains code that handles the exception if it occurs. The finally block contains code that will execute regardless of whether an exception occurred or not. The finally block is a crucial part of exception handling in Java. Let's understand its key characteristics. The code within the finally block always runs after the try and catch blocks, regardless of whether an exception was thrown or caught. The finally block is commonly used for resource management, such as closing files or releasing resources, ensuring that these operations are performed no matter what happens in the try-catch structure. Let's look at a simple example to illustrate how the finally block works. The try block contains code that tries to divide 10 by 0, which causes an arithmetic exception. The catch block catches this specific exception and prints a message. Regardless of whether the exception occurred, the finally block executes and prints finally block executed. The output is in try block caught an exception, / by 0, and finally block executed. While the finally block is a powerful feature for resource management and exception handling, it is important to be aware of its correct and incorrect usage. Let's first look at the correct usage. The primary purpose of the finally block is to ensure that cleanup code runs regardless of whether an exception was thrown or not. Here's an example. The try block attempts to open and read a file example.txt. If there is a problem, such as file not found, the catch block prints an error message. The finally block ensures the file is closed safely, preventing resource leaks. If closing fails, another error message is shown. Using the finally block to close database connections is another common and correct practice. Here, the Java program connects to a MySQL database, performs operations, and ensures the connection is properly closed. The try block attempts to establish a database connection. If there is an error such as wrong credentials or connection failure, the catch block prints an error message. The finally block ensures the database connection is closed, preventing potential memory leaks or locking issues. Next, let's see a few ways in which the finally block is used incorrectly. One common mistake is not handling exceptions that occur within the finally block itself. If an exception occurs in the finally block, it may suppress exceptions thrown in the try or catch blocks. In this example, the try block tries to divide 10 by 0, which causes an arithmetic exception. The catch block catches the error and prints an error message. The finally block also tries to divide 10 by 0, causing another error. However, errors in finally can override the original exception, making debugging difficult. In this case, if an exception occurs in the finally block, it can prevent the original exception from being handled properly. Another mistake is using a return statement inside a finally block. This can lead to unexpected behavior as it overrides any return statements from the try or catch blocks. Here, the Java program shows how a finally block can override return values, which can lead to unexpected behavior. The try block tries to return 1. If an exception occurs, the catch block would return 2. Since finally always runs, it overrides any previous return statements and returns 3 instead. Hence, the output is always 3. In this example, even though there are returns in both the try and catch blocks, the finally block's return statement takes precedence, leading to unexpected outcomes. Beginners might believe if an exception occurs, the finally block will not execute. This is incorrect. The finally block will always execute unless the program crashes or is forcibly terminated. In this example, the try block attempts to divide 10 by 0, causing an arithmetic exception. The catch block catches the error and prints a message. Since there's no finally block, there's no guaranteed cleanup such as closing resources. Hence, the program continues unless explicitly terminated. In this video, you learned that an important feature of Java is exception handling mechanism, which includes the try, catch, and finally blocks. The try block contains code that might throw an exception. The catch block contains code that handles the exception if it occurs. The finally block contains code that will execute regardless of whether an exception occurred or not. Using the finally block correctly involves always executing cleanup code and releasing database connections. Using the finally block incorrectly involves not handling exceptions within finally, using return statements, and assuming that if an exception occurs, the finally block will not execute. Welcome to this video about using multiple try-catch in Java. After watching this video about multiple try-catch in Java, you'll be able to explain try-catch exception handling, explain multiple try-catch exception handling, and describe the throws keyword. Java uses exceptions to provide error handling capabilities for its programs. Before you can catch an exception, the code must throw one. Any Java code can throw an exception. A throw expression is any kind of expression whose type is assignable to the Java throwable type or subclass. When an exception is thrown, it can be caught by the API, or a rule with a try-catch statement, or by any Java code. In Java, a try-catch block is used to handle exceptions that occur during the execution of a program. It helps you catch runtime errors, exceptions, and take appropriate actions, preventing your program from crashing. Here's the syntax of a basic try-catch statement. Here, the try-catch block contains the code that might throw an exception. The catch block handles the exception if it occurs. Multiple try-catch refers to the use of more than one catch block within a single try statement, or multiple try-catch statements in your code. This allows you to handle different types of exceptions separately, which is useful when you expect different kinds of errors from the same block of code. Here's a simple example demonstrating multiple catch blocks. Here we have two catch blocks to handle the array index out of bounds exception and arithmetic exception exceptions separately. The array index out of bounds exception occurs when we try to access an array with an invalid index, and the arithmetic exception occurs when there is an illegal arithmetic operation such as dividing by 0. Using multiple try-catch blocks in a program offers several advantages. You can write code that gracefully handles various exception conditions, leading to more robust and user-friendly programs. Additional benefits of multiple try-catch blocks include clearer error handling. Each exception can be handled individually, making debugging the code an easier effort. Specific responses. You can specify unique response messages based on the type of error, and code organization. Exception handling helps keep code organized and readable. In software applications, user inputs are often predictable. Using multiple try-catch blocks can help validate inputs effectively. Here we attempt to convert user input into an integer. If the input is not a valid number, a number format exception is thrown, and we handle it with a catch block. When working with files, multiple exceptions can arise, such as file not found or issues during reading and writing. Using multiple try-catch blocks can assist in handling file errors. Here, we attempt to read from a file that doesn't exist. If the file is not found, a file not found exception is caught. If there's any I/O issue when reading the file, an I/O exception is caught. The Java runtime system and many classes from Java packages throw exceptions in some circumstances by using the throw statement. Here's the syntax for using throws. Return type method name open parentheses parameters, close parentheses, throws exception type 1, exception type 2, open curly brace. You can use the throws keyword in method declaration to indicate that a method can throw one or more exceptions. This informs the caller of the method that they need to handle these exceptions, either with a try-catch block or by declaring them in their own method using throws. Using the throws keyword provides the following advantages. First, the separation of concerns enables each method to focus on its own logic without handling each possible exception. By declaring exceptions, method users can more clearly determine which error handling methods to implement to manage potential errors. And Java's robust code design capabilities lead to better error handling practices, which encourages developers to plan for exception management. Let's look at a simple example to understand how throws work. Here, the readFile method is defined with the throws IO exception clause. This means that this method might throw an IO exception if there's an issue with file reading. In the main method, we call readFile. Since it can throw an exception, we wrap this call in a try-catch block to handle the potential IO exception. If the specified file does not exist, the file reader will throw an IO exception, which is then caught by the catch block, allowing us to handle the error gracefully. In this video, you learned that Java uses exceptions to provide error handling capabilities for its programs. Any Java code can throw an exception. Exceptions can be caught by the API or a rule with a try-catch statement or by any Java code. The try-catch block is used to handle runtime exceptions and takes appropriate actions, preventing your program from crashing. Multiple try-catch refers to the use of one or more catch blocks within a single try statement or multiple try-catch statements in your code. The Java throws keyword provides separation of concerns and superior error handling benefits. Welcome to this video about checked and runtime exceptions in Java. After watching this video, you will be able to explain checked and runtime exceptions, compare checked and runtime exceptions, and describe the reasons for using checked and runtime exceptions. Checked exceptions are exceptions checked at compile time. This means that the Java compiler ensures that your code handles these exceptions before it can be successfully compiled. If your code does not handle a checked exception, it results in a compilation error. Checked exceptions have the following characteristics. The exception is typically caught using a try-catch block or declared in the method signature using the throws keyword. The exception represents recoverable conditions such as file not found or network issues. Let's look at a simple checked exception example involving file handling. Here, we create a new file object pointing to non-existent file.txt. Then we initialize a scanner object to read the file object. Since the file may not exist, we wrap our code in a try-catch block to handle the file not found exception error, which is a checked exception. When the program is run, it prints an error message because non-existent file.txt cannot be found. Checked exceptions are used during the following: file operations such as reading from or writing to a file, database connections such as connecting to a database, network communications such as making network calls. Runtime exceptions are not checked at compile time. These exceptions occur during the execution of the program and can often be avoided by fixing the code. The Java compiler does not require you to handle or declare runtime exceptions. Runtime exceptions have the following characteristics. The exceptions do not need to be explicitly caught or declared. The exceptions indicate programming errors, such as logic errors or improper use of APIs. Let's consider a simple runtime exception example involving division. Here, we attempt a division operation to divide 10 by 0. Since dividing by 0 will trigger an arithmetic exception, we catch this exception in a try-catch block. Our Java program catches the exception and prints an appropriate message. Runtime exceptions are used to display arithmetic errors such as division by 0 or overflow errors, null pointer access errors when you try to access an object that has not been initialized, array index out-of-bound errors when you access invalid indices in arrays or collections. Let's compare checked exceptions with runtime exceptions. First, let's examine when they are used. Checked exceptions are discovered and reviewed at compile time, while runtime exceptions occur as the program runs. So, why identify exceptions? You would identify checked exceptions to handle exception recovery from external events such as files not found, network issues, and other issues outside of the code. However, you would identify runtime exceptions to handle programming errors that need to be fixed, such as log errors, null references, and other problematic issues. Checked exceptions often help applications recover from errors. Checked and runtime exceptions have different handling requirements. Java requires that checked exceptions are caught using the try-catch method or declared using throws before you can compile the code. In contrast, Java does not have mandatory handling requirements for runtime exceptions, and you might be able to ignore them. I/O exception, file not found exception, and class not found exception are examples of checked exceptions in Java that must be explicitly handled. I/O exception is commonly used for handling file operations and network communications. File not found exception for missing file issues, and class not found exception when attempting to load classes dynamically at runtime. In contrast, you can use runtime exceptions such as null pointer exception to identify when the code is trying to use a null reference, arithmetic exception to identify invalid mathematical operations, and array index out of bound exception to notify you when the code is accessing array elements outside valid indices. Checked exceptions provide the following benefits. Compile time safety. Checked exceptions require developers to handle potential error scenarios at compile time. This reduces the chances of unhandled exceptions occurring during execution, leading to more stable applications. Recoverable errors. Checked exceptions typically represent conditions that a program can anticipate and recover from, such as file not found or invalid user input. This encourages developers to implement error handling mechanisms to manage these situations gracefully. Clear API contracts. By declaring checked exceptions in method signatures, APIs communicate the possible issues that may arise when using them. This helps users of the API understand what exceptions they need to handle, leading to better code practices. Promotes defensive programming. Using checked exceptions encourages developers to think proactively about error handling, leading to more robust and resilient software. Runtime exceptions provide the following benefits. Simplicity. Runtime exceptions do not require explicit handling, which simplifies the code. Developers can focus on the main logic without being burdened by mandatory error handling for every potential issue. Indication of programming errors. Runtime exceptions usually indicate bugs or logical errors in the code. For example, null pointer access, array index out of bounds. Using runtime exceptions allows developers to catch and fix these issues during development rather than at runtime. Performance. Since runtime exceptions do not require checked handling, they can lead to cleaner and more efficient code, especially in performance-critical sections of an application. Control flow. Runtime exceptions can be used to signal problems that should not occur if the program logic is correct. This allows developers to implement custom logic for handling unexpected conditions without cluttering the code with error handling structures. In this video, you learned that checked exceptions are exceptions checked at compile time. The Java compiler checks exceptions to ensure your program can be successfully compiled before execution. Checked exceptions are caught using a try-catch block or declared in the method signature using the throws keyword. Checked exceptions are used during file operations, database connection, and network communication. Runtime exceptions are not checked at compile time. They occur during the execution of the program and can often be avoided by fixing the code. Runtime exceptions display arithmetic errors, null pointer access errors, and array index out of bound errors. Checked exceptions provide benefits such as compile time safety, recoverable errors, clear API contracts, and defensive programming. Runtime exceptions provide benefits such as simplicity, indication of programming errors, performance, and control flow. Congratulations on completing this course. Now that you have a comprehensive understanding of Java, such as setting up the Java environment, using programming constructs, control structures, string handling, and exception handling, you are all set to continue learning and applying your skills in the real world. But first, let's review some key concepts you learned throughout the course. Java is a versatile programming language used in web apps, mobile apps, and enterprise software. The Java ecosystem comprises various tools, libraries, frameworks, and platforms. The Java Virtual Machine, or JVM, converts Java bytecode into machine code, making Java platform independent. The Java Development Kit, or JDK, contains the JRE and development tools. It is used for building, compiling, and running Java applications. The Java Runtime Environment, or JRE, provides the environment to run Java applications. Some of Java's key features are object-oriented programming, platform independence, strong typing, automatic memory management, multi-threading, a comprehensive standard library, built-in security features, and versatility across domains. Comments serve as notes within the code that are not run by the program. They enhance clarity, maintenance, and collaboration. Data types are containers for specific information. Operators instruct the Java compiler to perform mathematical or logical operations. Arrays are collections of elements of the same type stored in contiguous memory. The process for creating and using an array includes array declaration, initialization, accessing elements, and finally, iteration using loops. Conditional statements direct a program to perform specific actions based on conditions. Loops enable repeated performance of a block of code, and strings are sequences of characters including spaces and punctuation. Packages organize related classes and interfaces. Imports allow access to external classes using the import keyword. A function is a standalone block of reusable code. A method is a function associated with a class. Methods can access instance variables, while functions remain independent. An exception is an event that disrupts the normal flow of a program. Exceptions provide a way to handle errors gracefully without crashing the program. The finally block contains code that will run regardless of whether an exception occurred or not. Multiple try-catch refers to the use of more than one catch block within a single try statement or multiple try-catch statements in your code. Checked exceptions are exceptions checked at compile time. Runtime exceptions occur during the execution of the program and can often be avoided by fixing the code. You'll apply the Java skills you practiced throughout this course to build a practical real-life grocery store calculator application. Congratulations on completing this course, and good luck on your continued learning journey.